Hello viewers, in the last lecture we have seen how to use the DH procedure to fix the coordinate frame at each joint of a robot manipulator and find the parameters of the manipulator at each joint. The 4 parameters: joint angle, joint distance, link length and link twist angle. So, in this lecture we will see how to using 3 examples, we will see how to find the direct kinematic equation for the for robot manipulators. So, as a first example, we see a 3 link manipulator in the as shown in the following picture. So, the manipulator is having the axis of rotation is the vertical axis and one horizontal axis which is perpendicular to the plane of the paper. So, we call this as the Z0 axis and the perpendicular to that as the Z1 axis. So, these are the 2 degrees of freedom situated at the single joint, we call it as O. Then the robot manipulator, if it is in this form, let us assume that so the robot manipulator, it rotates in the horizontal plane with the axis Z0 and it rotates in the vertical in the plane of the paper with the axis Z1, both of them situated at the joint O, and at the joint A there is a prismatic joint, it will slide forward and backward. So, these are the 3 axes of this particular manipulator. The end effector is the point B, the axis, the approach direction we call it as, this axis is Z2 and the approach direction is Z3. So, this is according to the DH procedure, the axis of rotation and the sliding direction, these are the Z axis to be fixed at each joint. Now, the X axis can be fixed by the following method. For the base Z0 axis, we can fix the X0 in this same direction and Y0 axis is fixed according to the right hand rule system. The X1 axis is given by the perpendicular direction to Z0 and Z1. In fact, it is ZK minus 1 cross ZK, that will give the XK axis. So, X1 axis will be Z0 cross Z1. So, it will coincide in this particular situation with X0 itself, the same as X0 direction in this picture, but if it is in a different position in a rotation, then X0 and X1 will be in a different directions. Then X2 direction is Z1 cross Z2. Z1 is this direction, Z2 is the direction given here, this direction. Then the cross product will give the axis. So, the X2 axis is pointing downwards in this particular situation. The origin at each joint already explained in the DH procedure is the intersection of the z axis. So, all the origins are fixed at the same position here. O is the origin of the base coordinate frame, then O1 is the origin of the x1, z1, y1 frame, and O2 is the origin of x2, y2, z2 frame. All of them are situated at the same position O only here. So, according to this procedure, we can formulate the 4 parameters of the robot manipulator. The first, second, third joint, there are 3 joint here. Theta is the joint angle, D is joint distance, alpha is the twist angle, and A is the link length. So, here theta 1 and theta 2 are the variables, because these two are the revolute joint, and the third one is the prismatic joint. The two z axes are parallel. So, the third one is a constant. The joint angle is fixed here. The joint distance, all the origins are coinciding at the same position. So, here the joint distances are all 0, first and second. The third one is OB, because the end effector position is at B, the origin is here. The joint distance, the definition of the joint distance, if you see that the joint distance dk is the distance between the two origins, which is given here O2, and then O3 is the origin of the third link here. So, OB is the joint distance here. Then alpha is the twist angle, alpha is the angle between the Z0 axis and Z1 axis. So, that gives the angle to be pi by 2, and Z1 axis and Z2 axis, that is again the angle pi by 2, and Z2 axis and Z3 axis, they are in the same direction, that is 0. And if two Z axes are parallel, then the link length is the shortest distance between the two Z axis. So, here we can see that because all the origins are fixed at the same joint, the link length, all of them will be equal to 0. So, this gives the robot parameters according to the DH algorithm. In the previous lecture, we have seen how to construct the coordinate homogeneous transformation, the ith coordinate frame with respect to the I-1 coordinate frame in terms of the homogeneous transformation is given by this 4 by 4 matrix, where this theta I, di, alpha I, ai are the corresponding joint parameters. So, if you take the first joint parameter, that is theta 1 and d1 is 0, alpha 1 is pi by 2 and a1 is 0. So, if you substitute these values in I equal to 1, we get the matrix 0 T1. So, we will get the matrix as follows: 0 T1 is given by this expression, and 1 T2. For 1 T2 we should substitute the values of the parameters theta 2 and alpha is pi by 2. If you substitute, we get the second 1 T2 matrix, and 2 T3 is given by the third one. If you substitute, D3 is the distance OB. So, that expression is given by, and theta is the angle 0 in this case. If you substitute here, we get the identity matrix for the first 3 by 3 matrix and 0 0 D3. So, these 3 matrix give the joint coordinate systems. Now, if you multiply all these 3, we get the 0 T3 homogeneous transformation, which gives the end effector coordinate frame with respect to the base coordinate frame 0. So, the product finally will give 0 T3 is given by the expression given here in terms of theta 1, theta 2 and D3. These are the 3 variables, theta 1, theta 2 and D3 variables are there. And so, for a given end effector position with respect to the base, if 0 T3 is given by a homogeneous transformation like this, then by comparing each element of the 2 matrix, we will get a system of equations in theta 1, theta 2 and D3. So, solving this system of equation, we will get the inverse kinematic solution of the problem. So, that we will see in the another lecture, how to solve the inverse kinematic problem for a given end effector position. So, now we will see another example for illustrating the DH parameter in a more detailed way. So, here we consider a 4 axis SCARA robot manipulator. So, the manipulator which we will consider is the following. We consider the base is revolving about the axis, z axis, z0 axis is a vertical line, and so this joint is a fixed one, there is no movement at this joint. We call the base as O and this joint as A, where there is no movement, it is 90 degree L shaped position. And at this joint B, there is a axis of rotation which is parallel to Z0 axis in the opposite direction. So, the rotation at this joint is performed in this direction, that is opposite to the Z0 direction, the performance of the rotation is done. Then at this joint C, there is a sliding movement, it is a prismatic joint. So, this joint will enable the link to move up and down in this direction, vertical direction. So, this will be according to the DH algorithm, the sliding direction is the Z axis. So, this axis is Z1 and this is Z2 axis. Now, at this joint D, this position, there is again a rotational motion similar to Z1. They are parallel, Z1 and here we call it as Z3 axis. Both of them are always parallel and the rotation direction is similar. So, finally, the end effector position. So, when there is an end effector, the approach direction, which is the end effector's Z axis, we call it as Z4. So, this robot manipulator, it is very clear that the end effector will always point downwards and it will move vertically up and down only. It will not tilt in any other x and y direction, only vertically it can go down or up, or it will rotate about the Z4 axis. So, now we can fix the coordinate frames at each joint as given in the DH algorithm. So, Z0 is fixed, Z1 is fixed, and the origin is the base here. We can fix the x0 and y0 axis arbitrarily according to the right hand system rule. So, we can fix arbitrarily x0 and then accordingly y0 is fixed. Then the z0 axis and z1 axis, they are always parallel in all positions. The shortest perpendicular distance, the shortest distance line or a line perpendicular to both z0 and z1 is AB direction itself. So, that is intersecting z1 at the point B here. So, this point B will become the origin of a new coordinate frame with z1 axis. Similarly, z1 and z2, they are always parallel. So, the shortest distance line, it meets the z2 axis at the point C. So, that will become the origin of the coordinate frame with z2 axis. Now, z2 and z3, they are the same line, they are in the same direction. So, they are intersecting at all the points. So, we can select a convenient point as the origin. So, the convenient point is D itself, this point. So, we can call this as O3. The origin is the point D itself. Similarly, Z3 and Z4 are in the same direction. We can select the point, the end effector point, this is C, D, this is E. The end effector point E as the origin, we call it as O4. So, first we have fixed the origin at each joint here. Then according to the procedure, we can fix the x direction. So, Z0 and Z1 are parallel. So, the common perpendicular line is the x1 axis. So, we can say that the line BC act as the x1 axis in this particular position. Similarly, Z1 and Z2 are parallel. The line extension of the line BC will act as x2 axis. And now, Z2 and Z3 are in the same direction. So, they are intersecting at all the points. So, any line perpendicular to both of them is called the x3 axis. So, we can select a convenient direction which is actually parallel to x2 axis. We can select the line x3 which is parallel to x2 as the x3 axis here. And in the same way, the end effector Z4 is already fixed, and according to the convention, the line joining the two fingers of the end effector is called the sliding direction. That is always called the y direction. The approach direction is always called z direction, and the line joining the fingers, two finger of the end effector is called the sliding direction, y direction. And then x direction can be fixed accordingly by right hand system. So, the direction x4 can be fixed here. So, at each joint now we have fixed the x, y, z axis, and the corresponding origins are also fixed already. Now, we should find the robot parameters, the 4 parameters of the robot manipulator. For fixing that, there is a point to be fixed in the according to the DH algorithm, the point BK is the point of intersection of xk and zk minus 1. So, for example, if you take z0 and x1, z0 is this direction, x1 is in this direction, when where they intersect is at the point A, z0 and x1. So, that point is called B1, and x2 and z1, x2 is this direction, z1 is given in this direction, they are intersecting at the point B. So, that point is called B2, and x3 and z2, x3 is in this direction, z2 is here, they are intersecting at the point D here. So, this point is called B3. So, similarly, the last point we can call it as B4, the O4 is called B4. So, this point is important to find the joint distance. Joint distance dk is the distance between OK minus 1 and BK. Once the point BK is fixed, we can we know the origin. So, the first origin is O0, the base is O, we can call it as O0, and B1, this distance. So, OA is called the distance D1, and O1 and B2. So, O1 is here the point B, and B2 is also the same point. So, we can say that D2 is 0, it is at the point O1 and B2 are at the same positions, therefore, D2 is 0. Similarly, O2 and B3, O2 is here, B3 is here. So, the length CD is called the D3. So, we can find the joint distance according to this particular rule. The link length that is AK is the distance between OK and BK, this 2 point. So, if you take for example O1 and B1, O1 is at the point capital B and B1 is at the point capital A. So, this distance is called A1 according to the DH procedure. Similarly, O2 is at the point C and B2 is at the point capital B. So, the distance between B and C we can call it as A2, and other values are O3 and B3, they are at the same position, therefore, A3 value is 0 and O4 and B4 at the same place. So, A4 will be 0. So, we get the 3 this one dk joint distance and link length AK. Now, the twist angle is the angle between the two z directions. So, z0 is pointing upwards, Z1 is pointing downwards. So, the angle between these two is 180 degree. So, the link twist angle is alpha k is angle between zk minus 1 and zk rotated about xk axis. So, these are the 4 points we have to note down. This is the first one, the second, the third point, and the twist angle is the fourth point. So, if you see Z0 and Z1 and it is revolving around the x1 axis, we get 180 degree, that is alpha 1 angle. And similarly Z1 and Z2, these two are parallel. So, the angle between them are 0. Similarly Z2, Z3, Z3, Z4, they are in the same direction, therefore, the angles are 0. So, what we get is the 4 parameters of the robot manipulator can be obtained in the following manner. Here there are 4 joints 1, 2, 3, 4 theta, d, alpha, a. So, we see that theta 1, theta 2 and theta 4, these are the revolute joint 1, 2 and 4, they are rotational. The third joint is the prismatic. So, theta 1 is a variable, theta 2 is a variable, theta 4 is a variable, and the D4, D3 is the thing. The first one is D1, that is OA as shown here. D2 is 0 according to this rule, and D3 is the length CD, C to D, that is given by CD, and D4 is given by DE. This angle is 0, the angle between the third one, it is 0 angle. Now, alpha 1 is 180 degree for the first Z0 and Z1, they have 180 degree between them. Z1 and Z2 are 0, they are parallel. Z2 and Z3 in the same direction, that angle is 0, and the fourth one Z3, Z4 in the same direction. Similarly, A1, AB, this point, that distance is called A1, and BC is called A2, and A3, A4, these two are 0 according to this particular rule. So, we get the 4 parameters at the 4 joints. Now, substituting that in the general expression, as we have seen, this is the general expression ith coordinate frame with respect to I minus 1 frame. So, we get 0 T1, 1 T2 etc. by substituting the values from this expression. So, what we observe is 0 T1 when we substitute theta 1, for D1 we substitute OA, that length. This is actually, so first joint is OA. So, the first joint distance d1 is OA. So, we substitute in the place of d1 this one, and A1 in the place of A1 we substitute the distance AB, whatever is the length AB. Similarly, for A2 we substitute the length BC depending on the size of the robot manipulator, and D3 is a variable because the third joint is a prismatic joint, it is varying from the value, that is the lowest value is 0 and the highest value is the length of that particular link. The maximum length of the link can be the highest value for that variable. So, now D4 is the final this thing, this is DE from up to the end effector to the previous link. So, these values can be substituted, and by multiplying the 4 matrix 0 T1, 1 T2, 2 T3 and 3 T4, we get the end effector position. Finally, the product will give the this thing. This is called the ARM matrix. The end effector with respect to the base is given by this one. So, in the next lecture we can see the inverse kinematic solution for this type of problem. So, in this lecture we have seen the 2 examples for illustrating the direct kinematics of the robot manipulator. In the next lecture we will see more examples and their inverse kinematic solutions. Thank you.